Now the next topic states buoyancy. What is buoyancy? It is a phenomena due to which any particular body which is submerged in any kind of fluid experience an upward thrust or upward force. So basically what is happening, we have fluid, okay, and there is this body which is submerged inside this fluid. Now the normal force which we already know about this thing that the body will be experiencing is the weight of the body, but that is where buoyancy comes into play. If a body is submerged inside any fluid, the body is going to experience an upward force which is called thrust or upward thrust, or generally it is called buoyant force, okay. So this upward thrust or buoyant force is acted on this body, due to which the weight or the effective weight of the body decreases. This phenomenon is called buoyancy. The greatest explanation of this buoyancy principle was given by Archimedes. Archimedes principle states that, okay, it states that the upward thrust experienced by a body which is placed inside any other fluid is equal to the weight of liquid displaced. So the principle states that upward thrust or upward force experienced by the body is equal to weight of the liquid. Basically right now we are doing fluids, and liquid is in the category of fluid. So Archimedes principle is majorly used in the case of liquid only, but otherwise it's applicable on the fluids. So if you want to write fluids in case instead of liquid here, you can do that. Weight of the liquid displaced. Alright. This is the principle on which the manufacturing of all these ships are based, and it started right in the medieval time, like medieval history time, where when the starting of sailing happens, not just medieval, actually ancient time, when the construction of ships and boats happened, because you know ships are made up of iron, right? They are iron casted, but still they are able to flow on the sea. So before that people used to know only wood can float on the water, so they used to build up ships or boats by wood, but later on it was made up of complete metal and still it was able to float. The point is, how did that happen? Because of the Archimedes principle. Now see how principle explains it. Weight of the liquid is placed. I'll use a normal body, a rectangular shape body, for which it will be easier for us to know the dimensions, right? Suppose there is a rectangular slab which is submerged inside this fluid. Okay, we can also consider that the height h, the height is h for the rectangular slab, whereas it is x distance below the free surface. That means it is at a depth, the upper surface of this slab is at x depth below the free surface, right? Now let A be the area of cross section of the plane, this face, the top face and the bottom face. So if I talk about the pressure P1 experienced by this face, P1 would be what? P1 would be, pressure is what? We have already studied the formula of pressure inside fluid is H rho g. H is the height, which is x in this case, rho is the density of fluid, and density of fluid or the density of body in this case. It is equal to density of fluid, because we are talking about pressure at this point inside the fluid, x, rho and g, right? So according to this pressure, what will be the force F1 which is acting on the top face? This force is now, what is this force, where is this force acting? We have already studied this fact that if a body is placed inside a fluid, the forces from the fluid will act normally on all the surfaces, not just top and bottom, in fact all the surfaces. But since we have taken a symmetrical figure, so all the sidewise force will cancel out each other, though the forces on the top and bottom side can also cancel out each other. It just depends on the value, if it is greater or larger, right? So force F1 which is acting vertically downward, or the downward thrust in this case, would be P1 times A. What is P1? This x rho g times A, right? Similarly, the pressure P2 which is acting at this point on the lower surface, this is equal to the pressure inside the fluid at this height, which is x plus h, becomes x plus h rho g, right? Therefore force F2, so upward thrust F2 on the bottom face would be equal to this into area, whereas x plus h rho g times area A. So clearly F2 is greater than F1. So when a body is submerged inside a fluid, the two vertical forces means the forces which are acting in vertical y-axis direction, one is F1 which is this much and one is F2 which is this much, and we know that F2 is greater than F1. That means this net force is tending to move the body vertically upwards because the downward force is greater. That means this force, the force which is acting on the upward direction, right? So net force will be what? F2 minus F1, which is equal to x plus h rho g A. If I open this bracket up, I'll get x rho g A plus h rho g A, right? Minus this F1, which is x rho g A. So I'm left with net force, which is in vertically upward direction, is h rho g A. Now this h and a, this becomes what? Volume of the whole solid, right? Because we have taken that either you take it cubical body or you take it a rectangular slab, whatever, this area of cross section into height gives you the volume. So volume into density into acceleration due to gravity. Now volume into density is what? According to the formula of density, density is mass per unit volume. So this is the mass, density into volume. So this is giving you mass into g. Now what is this mass about? This is the volume density, this is the densities, the density is of the liquid displaced, and the volume is also of the liquid displaced, because the liquid, the amount of liquid or the volume of liquid which will be displaced on submerging this body will be equal to the volume of this body. That means even if it is the volume of the solid, it is equal to the volume of fluid displaced, right? Therefore volume of liquid is equal to volume of solid. That is why I have taken it here L, and this expression from here gives me, this becomes mass of the fluid displaced, mg, or m into g is what? This is equal to weight of the liquid displaced. So this proves Archimedes' principle that when a body is submerged inside a fluid, it will experience an upward force which is called buoyant force, and its value will be equal to the weight of liquid or weight of fluid displaced. So based on this principle, law of flotation gets its validity. What does now law of flotation states? If I drop a body inside a fluid or on a fluid, what will happen? There is a probability of 3 cases. 1, 2, 3. In the first case, the body can completely submerge. That is because weight and upthrust, the two forces, that means weight was greater than upthrust. In second case, the body can float on the water, partially immersed. That means weight and upthrust, weight is equal to upthrust. This is what it means. Whereas in one case, body can remain completely above the water or above the liquid. In that case, upthrust and weight, upthrust is greater than weight. That is the only possibility. That means when this body was about to get submerged, it was displacing an amount of liquid for which the weight comes out to be greater than the weight of the body itself. That is why it did not sink at all. So the condition where body is going to sink to the bottom is only when the weight of the body is greater than weight of the fluid displaced. This is called law of flotation.